Hello, Atlassian team. My name is Tomas Gonzalez. I'm a partner solutions architect at Snyk. And today this session is called Rise of the Secure Developer. How being a developer today is not how being a developer used to be 10 years ago. So to set the stage, let's get us started. What has fundamentally changed for developers as they build cloud native? Applications look a lot different now than they used to. Now applications consist largely of open source components, which has allowed developers to instead of writing every bit of the application themselves, they're almost playing Tetris, where they can look for libraries in the open source community that meet most common use cases. Do you need a database driver? Do you need a message queue? Do you need an authentication module? Very likely there are open source components that are maintained by the community that can meet a lot of these use cases, so that me as a developer, I can focus on the glue that holds all these components together, my secret sauce, my proprietary competitive advantage. Second, I now have so much power at my fingertips thanks to the cloud. I can provision compute, database, serverless runtimes, all in a self-service manner. In many cases, I can actually define that as code. And because of open standards in use across multiple hyperscale providers, I'm able to build workloads with portability in mind. A container is a container, for example, and I build it for Kubernetes on AWS. It should work on Kubernetes on Azure. And finally, the way that our organizations build software is changing. Organizations are moving towards agile development methodologies, where as developers we're encouraged to be innovative, to try things, and see how we can help our organizations develop our competitive advantage. This, combined with the faster feedback loops and this ability to try and fail fast, has radically sped up the pace of innovation. Now, so what does this mean? What does my application look like today? Well, it means that around 20 to 30% of my code, the glue that holds together these open source components, that secret sauce, is proprietary. The rest of my application is largely consisting of open source components. These are all the libraries that meet common use cases that the community has provided. I might be packaging these applications into containers for the interest of portability and standardization across different hyperscale providers, and deploying those applications, those containers, into infrastructure defined as code. So infrastructure is now part of my application. This is different because before the cloud, there was a very clear division of responsibility. As a developer, I was responsible for the code I wrote, the open source components I used, and I had an IT and operations team that would provide the golden image, the infrastructure. I had to request a server with this much storage, this much memory, these networking rules, open and close. And that has completely changed with the cloud. As a developer, with infrastructure defined as code and with containers as my preferred packaging mechanism, I now have the ability to interact with more parts of the stack than I ever did before, which has put a lot of power into my hands for that rapid iteration and that rapid playing with new features. But as my organization has undergone this digital transformation to put all this power into my hands, inadvertently so has been the case that the responsibility for vulnerabilities in the configuration of those workloads, in the networking rules for how that infrastructure is configured, is now within my realm of responsibility. I'm able to mutate an infrastructure as code template to serve my needs, and this just means I have a lot more power, but also I own a lot more of the risk. So how does this manifest into my day-to-day, really? What are the struggles around this? Well, number one, when I'm writing code, I need to be cognizant that my KPIs are to release. I need new features, I need new functionality, I need to fix bugs. And with the pressure from the new ways of building and delivering software, these agile methodologies, I might find myself taking shortcuts in order to meet my deadlines, but still being responsible for the risk and for the security of the code I'm writing. With open source, it's wonderful that I don't have to write many modules of my application from scratch. I can just tap into the community. But these packages, they need to be vetted for security vulnerabilities. They need to be vetted for license compliance to make sure that I'm not taking an implementation decision that ends up putting my company's intellectual property at risk. And even after I release these applications, I need to consider that new vulnerabilities are disclosed on a daily basis. And that might result in an ongoing maintenance cost of, because I used an open source component, I now am in charge of keeping it healthy. By choosing to package my application in a container, I might inadvertently be pulling in hundreds of packages from public sources. I might be using more libraries in my container than my application actually needs. And that operating system in that container might be configured in a way that's not to my company's best practices and policies. Extending that to infrastructure as code, with infrastructure being part of the application, I need to also be an infrastructure expert. I need to make sure my load balancers are not open to the world. My S3 buckets are not left unencrypted and publicly facing. And these are pressures that extend beyond the development team. There are multiple stakeholders that play a part in making sure that all these things are checked for and attested for as part of my delivery process. Let's visualize it in context of a tool chain. So I'm considering that my extended team, my operations teams, my security teams, my license compliance team, this is all the development team. Their decisions influence my day-to-day. So what does this mean? I mentioned there's 100 of us developers whose main concern is to push code faster. And if you try to tell me that security is a top-down mandated thing without a lot of context or a lot of information on how to actually fix it and get back to developing, I might just ignore it for the sake of my primary KPI, which is to push code faster, to create new features, and to continue innovating on my company's competitive advantage. My operations or my DevOps team, there might be 10 of those versus my 100 developers. They're concerned with keeping our applications in production running. Their primary KPI is the uptime of those applications. And as part of maintaining the delivery pipelines to keep the application running, they also need to integrate security and other types of testing, testing tools that automate tests, to maybe do feature flag deployments. And all these tools, they're in charge of making sure they're actually getting used. Nobody wants to be on the operations team having to do a break glass on a security vulnerability gate because we want to deploy to production, we need to maintain uptime, but we haven't gotten around to fixing a security issue. All along the tool chain, I also have the most important stakeholders on my team, the ones that are actually deciding what is the concept of acceptable risk for my production environment. Security engineering, security compliance, legal license compliance, they're the ones that are setting the guidelines for what I can and cannot do. And so it's very easy to see how everybody with different KPIs, with different pressures, might all be trying to pull in different directions to make sure their KPIs are met. And this has historically resulted in a very difficult way of working. So for example, as a developer, if a security team gives me a full list of all the vulnerabilities in my code, in my infrastructure, but they're not really telling me what's most urgent, or they're not telling me what I should fix, or maybe even not telling me soon after I wrote that code, I might be hesitant to pick that up because my mind went elsewhere. I've been working on other projects. I have to now transport myself back in time, think about what I was implementing at the time, why I took that decision, and then work around it. Second, if I get a list of vulnerabilities that don't really consider how my application is running or deployed into production, for example, if I have a stateless workload, but somebody is telling me to fix an issue in an open source component that interacts with a database and my application is not interacting with the database, that doesn't really help me cut through the noise and figure out what needs to be fixed most importantly. Third is the concept of unreal expectations. Don't tell me that I can't deploy to production unless I fix 900 vulnerabilities. I wouldn't even know where to start. And I would probably play the card that, are you sure you want to risk production downtime just because of a few vulnerabilities? The application already works. It's been deployed. It's been running. So these are things that have historically caused friction between these different stakeholders who all have these different KPIs that all want to make sure their part of the equation is done. So what can we do about it? We can think of DevOps as requiring security that enables developers. This is a security strategy that allows the security team, the legal license compliance team, to create guardrails or codify the acceptable risk of my production environment into guidance that then lets me, as a developer, take action on what I need to be fixing the most. Let's think about this in practice. So first off, there was an exercise done by our security team to define the level of risk that is allowed in my production environment. Let's say they arrived at the conclusion that production should have no critical or high severity vulnerabilities. For now, we're okay with mediums and lows. So what does that manifest as? It manifests as when I'm working on my workstation or when I'm checking code into my Git repository, my security tools are actually presenting the information according to that level of acceptable risk within my working environment. And because I know, and that policy was communicated to me, I can focus on fixing just the things I know that are going to break the pipeline, at least to start. That still lets my operations team introduce gates into the pipeline because the security risk was created as a policy and it was communicated. And as a developer, I know what's going to break the pipeline. I'm able to take into account all those decisions while I'm working on the application to make sure that I'm not breaking the operations team's pipeline by triggering the quality gate. I'm then also able to enrich the information that I see in my workstation using context for how my application is going to be deployed. So you think about my example for the stateless workload. If I know my application is not going to be connected to a database and it's just that one particular service, and that service has vulnerabilities that are database specific, I need to be able to sort through that noise and follow through on what's actually important. Then I might actually ask for help on that ongoing maintenance of open source components for my application. If there is a way for a tool or one of my extended team members to open up a pull request with the required fix that then goes through all my unit integration and functional testing without me even breaking a sweat, when I come in the next day to try to see what new things I should be working on today, all my automation is going to have validated and vetted that fix, which makes my job triaging that vulnerability or upgrading that component much simpler, because now all I have to do is verify that my pipelines ran, deploy my application to a pre-production staging environment, make sure it all functions, and that's it. I can fix the issues quickly. So what does this look like in the big picture? It means that legal and license compliance teams can create license policies that allow me as a developer to use open source. It gives me that competitive advantage. I can tap into the wealth of knowledge from the community, but in a safe way, in a way that warns me early if I'm using an open source component with an unsupported or incompatible license. My security and operations teams can create threat models that are then manifested into the platform as policies to help influence what vulnerabilities I should be focusing on first. This allows the operations teams to clearly communicate and codify into the pipeline what would break the deployment. And because that expectation is set with the developers, I can reduce the number of times I override the gates, because at the end of the day, my developers are now empowered. They know what breaks the pipeline. There has been communication on what acceptable risk in the environment is, and that information has manifested into their development flow. So, to recap, what works? It's this concept of shared responsibility. Those wearing the security, the compliance hats, defined what the acceptable risk is, codified it into my security tools, and those manifest as guardrails to give the developers the freedom to innovate and create in a safe way. Second, because those expectations were clearly communicated, we're all on the same page around what is acceptable risk and what breaks our production deployment pipelines. This allows us to make sure that we're complying with the security objectives and the license compliance objectives at the organizational level before the pipeline is triggered, to reduce the number of times that we have to break glass. And third, it's really presenting information in context of the tools that developers are using. I want to see this information in my IDE, so I don't have to go into a different console to review the results. Show me the information that I need to see inline so that I can quickly fix it. And that is what leads to the rise of the secure developer. Shared responsibility of security, so developers can be security champions so that we can sustain production uptime through communication of what would cause downtime, so I can focus on just the things within my workflows that my organization needs me to focus on. Thank you very much